Today in this class we are going to discuss about correlation. Till now we are studying about mean, median, mode. In mean, median, mode we are only taking one variable and we are trying to find the mean, median or mode. But in case of correlation we take two or more variables and we check how these variables are correlated. What is the relationship between the two variables? That is called correlation. Let us start the class. So, correlation is the relationship between two or more variables. You can take any variable like height and weight. Suppose the height is increasing, then the weight is also increasing or decreasing. That we can find or we can relate these two variables. How it is related? How height is related to weight. Maybe rainfall and yield. Rainfall is increasing. If rainfall is increasing, the yield of the crop is increasing or decreasing. That also we can relate. So many examples are there in case of correlation. Correlation is measured in terms of correlation index or correlation coefficient. We measure the correlation by correlation index or correlation coefficient. So correlation may be positively correlated or negatively correlated. If x value is increasing and also y value, x variable is increasing with y also increasing, or x is decreasing and y is decreasing, then it is called positive correlated. If two variables are there, then one is increasing, the other also increasing. May not be in the same rate, but it is increasing. Or one is decreasing and the other is also decreasing. We can say it is a positive correlation. But if one variable is increasing and the other is decreasing, or the other one variable is decreasing and the other is increasing, then we can say it is a negatively correlated. So these are the relationship we can find between two variables. The variables are positively correlated or negatively correlated. R varies from -1 to 1. Always the R is our correlation index or correlation coefficient. We measure the correlation index or correlation coefficient by R. R varies from -1 to 1. 0 to 1 is positive correlation. -1 to 0 is negative correlation. When we measure the R value, if R comes between 0 to 1, then we can say it is positively correlation. And if -1 to 0, then it is said to be negatively correlated. If it is very approaching to 1, means it is 0.8 or 0.9, then we can say strongly positive correlation because it is very close to 1. If it is 0.1 or 0.2, then in that case we can say it is very less correlation is there between the two variables, or weak correlation is there between the two variables. If it is approaching towards 1, very close to 1, like 0.8, 0.9, we can say strongly correlated. If it is 0.1, 0.2 like this, then we can say weakly correlated. The two variables are the correlation is very weak. -1 to 0 like that only we can say it is negative correlation. If it is very close to -1, then it is strongly correlated. It is close to 0, but it is negative, then we can say it is a negatively correlated. That we can discuss when we will discuss the examples. What are the methods to find the correlation? To find some methods are there like Karl Pearson's product moment method, Spearman's rank correlation method, scatter diagram, coefficient of concurrent deviation. These are the methods normally discussed to find our correlation. or to find the correlation coefficient. So first we will discuss about Karl Pearson's product moment method. Normally we discuss these two methods, and sometimes in the question exam it is asked what is scatter diagram. Okay. So first we will discuss about Karl Pearson's product moment method. Then we will go for Spearman's rank correlation. Let us start how we are going to calculate Karl Pearson's product moment method. First method is our Karl Pearson's method to find the correlation coefficient. So for Karl Pearson's method, different methods are used, like we can calculate the correlation coefficient by direct method, we can calculate by shortcut method, we can calculate by step deviation method. As we have already discussed in when we are studying mean median mode, we are using this direct method, shortcut method and step deviation method. So we know shortcut method is also known as assumed mean method, and step deviation method we use to make the calculations more easy. It is, you can say, it is an extension of your shortcut method, that's step deviation method. So first we will discuss direct method. We will take one example and see how we are going to calculate the correlation coefficient by Karl Pearson's method. X, here to calculate the R equal to, this is correlation coefficient R by Karl Pearson's method, equal to, you can write RK also because we are using Karl Pearson's method. RK equal to sigma of xy divided by root of sigma x square into sigma y square. So what is x, small y? I have taken here small x, small y. So for small x, you can write, or lowercase x equal to, this is the uppercase x minus x bar. X bar is nothing but our mean. We know x bar equal to sigma of x divided by n. Like that, y bar equal to sigma of y divided by n. That we have already discussed in mean median mode when we have discussed the central tendency. You can refer the previous videos for those. So RT equal to sigma of xy divided by root of sigma x square into sigma y square, and this is the lowercase x equal to, or small x equal to capital X minus x bar, and small y equal to capital Y minus y bar. X bar equal to sigma of x by n, y bar equal to sigma of y by n. Let us take one example and see how we are going to calculate the correlation coefficient. This is the question. Find the correlation coefficient by Karl Pearson's method. This question I have taken x value is given like 2, 3, 4, 5, 6, 7, 8. Y value is given 4, 5, 4, 7, 8, 9, 10, 14 and 18. This is the value of two variables. Okay. How we are going to calculate? First you see the formula. What we need? X is given, y is given. So we have to find the sigma x and sigma y, because we have to calculate x bar and y bar. So first do the summation of this. Sum of x, sigma of x equal to 2 plus 3, 5 plus 4, 9. 9 plus 5 is 14. 14 plus 6 is 20. 20 plus 7 is 27. 27 plus 8 is 35. You can take this one as 35. So this we can take 4 plus 7, 11. 11 plus 8, 19. 19 plus 9 is 28. 28 plus 10, 38. 38 plus 14. 38, 10, 48. 48 plus 4, 52. 52 plus 10, this is 62. 62 plus 8. Okay, this is yes, 70. This one is 70. 62 plus 8. This is 70. This is sigma 1. So we need to calculate x bar and y bar. X bar equal to 35 divided by, what is the number of n equal to 1, 2, 3, 4, 5, 6, 7. N equal to 7. So this is 5. Sigma of y, x bar and y bar equal to sigma of y divided by n, that is 70 by 7 equal to 10. One is 5, one is 10. So x bar equal to 5 and y bar equal to 10. What do we need? We need small x and small y we need to find, because we got x bar and y bar. Then we need to find x into y, then x square and y square. These values we need to calculate the RK or rank correlation coefficient. So let us find how we are going to calculate. This is small x, this is y, small y, then x into y, then we need to calculate x square and y square. So x we can take here, small x is x minus x bar, small y equal to y minus y bar. This is 5, x bar is 5, 2 minus 5 is minus 3, 3 minus 5 minus 2, minus 1, 0, 1, 2, 3. Here 4 minus 10 minus 6, 7 minus 3 minus 2 minus 1, this is 0, this is 4, this is 8. Now I will calculate x, y, x into y. 6 into 3, 18, 3 into 6, 3 into 2, 6, this is 2, this is 0, this is 0, 8, okay. Now we calculate x square. We need to calculate sigma of xy. So sigma of xy, we need to calculate sigma of xy equal to this 58. Now we calculate x square and y square. X square 9, this is 4, this is 1, 0, 1, 4, this is 9. This one 36, 9, 4, 1, 0, 60, 64. We need to calculate the sigma of x square and sigma of y square. So sigma of x square equal to, we get 28, and sigma of y square equal to 130. This is 130. Now put all the values to our RK, that is the rank correlation. if we are going to put the value, sigma of xy we know it is 58. 58 divided by root of, this is sigma x square is 28 into 130. If you calculate this value, it will come 0. That is 0.96. So 0.96 is our correlation coefficient. And we can write 0.9 is very close to 1. We can write these two variables are strongly correlated. As it is very close to, it's a positive value and close to 1, and we know positive correlation varies from 0 to 1. As it is very close to 1.96, so we can say these two variables x and y are very strongly correlated. If you see here how x is increasing, x is increasing here, increasing column, y is also increasing. Both are positive. X is increasing, y is also increasing. And the rate of increase also very close. The same rate they are increasing. So that's why you can say it is positively correlated and very strong positive correlation between x and